In this video, working through a problem from 8.2, a magazine claims that the mean amount spent by customers at Burger Stop is greater than the mean amount spent by customers at Fry World. So that is the claim, and that's what the first question is just asking about. What's the claim being made here? And we want our claim to be our alternative hypothesis, because if we can prove the alternative hypothesis by running the hypothesis test. So the fact that Burger Stop, they spend more than Fry World would look like the mean spent at Burger Stop is greater than the mean spent at Fry World. So that's what we want, which means our null hypothesis then is that the amount spent at Burger Stop is either less than or equal to Fry World. And so, like I mentioned, the alternative hypothesis is our claim. And here's all the information from our two samples. We took a sample at Burger Stop and we took a sample of information from Fry World. And we're going to see if there's enough information here for us to reject the null, which then would mean we accept the alternative hypothesis, which is our claim, and we will accept it as true if we can reject the null. Okay, so jumping into the book now, this is on page 428, right at the start of chapter 8.2. The formulas we're going to use with our sample data, it's going to depend if we have the two populations here, whether their variances are equal or not. And so our population 1 is the Burger Stop, and the population 2 is Fry World. And you can see this problem says that assume the population variances are equal. And so looking at this little table here, if the variances are equal, our standard error is going to require this formula here, which this little guy here is this long computation times that square root. But if the variances are not equal, then we use this formula for the standard error. And so make sure you're using the right one. I want to flip to the next page as well before I dive into solving this. For any problem, kind of combining here 8.1 and 8.2, there's a little flow chart to see if you're in 8.1 using the z-test, if we know the standard, the population standard deviations. Or if we don't know them, then we're in 8.2 here using the t-distribution rather than z-test and normal distribution. And like I just mentioned, we need to always ask, are the population variances equal or not? And then it depends which formula we're going to use as we proceed through the steps, which I will do now in Excel. So I'm going to get that pulled up. We have our null and our alternative listed. Here's all the data from the two samples. And so the first thing is the degrees of freedom. Well, how do we figure out the degrees of freedom? I meant to go back to the book. Again, on page 428, it says the degrees of freedom when the when the variances are equal. The degrees of freedom is you add the two sample sizes together and subtract 2. So that's different than what you would do if the variances are not equal. So in this case, we add the two sample sizes together. That would get 24. Subtract 2, you get 22. So our rejection region for a one-tailed test, we would use just t dot inverse is one-tailed. Let me click there so we can see the formula. We put our alpha in there, 0.05, and then our degrees of freedom. And Excel gives us back the probability, or sorry, not the probability, but the critical value for the rejection region for a left-tailed test. Now, ours is a greater than alternative, so we really want right-tailed tests, so our actual critical value is the positive version of that. But Excel only has a formula that gives the left-tailed, so this is our actual critical value here. Now, the standard deviation that we're going to use in our test statistic, for the test statistic, like we always do, we're going to subtract the two means, see the difference of the means, and then divide by that standard deviation. We need to use this long formula, and I've broken it up into chunks. I'm first going to calculate just this bit here, and then I'm going to calculate this square root, and then I'll finally do that multiplication of multiplying those two things together. So this is important. I'm going to try to leave it up here on the side of the screen. All right, bear with me with a little zoom in there. All right, so you can see this formula right here. Here's how it's looking as I typed it in Excel. The key is to make sure you're typing it in correctly, following the order of operations, or else the numbers can be a little bit off. So the first sample size minus 1, 13 minus 1 is 12, and multiply that by that first sample standard deviation squared. Add that to the second sample size minus 1, which is 10. 11 minus 1 is 10. And then that second sample standard deviation squared. And so that is the top part. And I got parentheses around that entire top part here. And then I want to divide by, this is the degrees of freedom, the two sample sizes added together divided by 1, which is 22. So we're dividing by 22. And we want the square root of that entire number. And then I want to do this next part of the formula. I don't know why it did that. Which is right here, the 1 divided by the first sample size plus 1 divided by the second sample size. And I'm doing that in my next box here in Excel. So 1 divided by 13 plus 1 divided by 11. Take the square root of all of that. So I have my two values here that I'm going to be multiplying together to get that standard error. And that's what I do here. I'm just taking those two values, multiplying them together, and that's my standard error. So now, let me come back in here. To get that test statistic, we're subtracting the two means. And that first mean should be 11.64. I'm not sure when that got changed. But subtract the two means from each other and divide by that standard deviation we just calculated. And when you do that, we get our test statistic. And if that's further away from 0 than our critical value, we're going to reject our null hypothesis. And 2.04 is further away than 1.71. It's more into the tail. And so because of that, we're going to reject the null and accept the alternative, which was the claim that BurgerStop customers spend more than Fry World.